This will be for the Kuta software worksheet, factoring trinomials a equals 1. Okay, for this worksheet, the equations will be in the form of ax squared plus bx plus c. So in order to factor, you want to find two numbers whose product is c and sum is b. In other words, you want two numbers that multiply to c and add to b. All right, so we're going to be writing out the factors of c, that is the constant term with no variable. All right, let's begin with number 3. This equation is in the form of ax squared plus bx plus c. They just use the variable m instead of x, but it's the same concept. And the reason this worksheet has a equals 1 in the title is because the coefficient or the number in front of the x squared or the m squared will always be 1. Okay, so in this case, when there's no coefficient in front of the variable, it's automatically 1. Okay, so in this case, in all the cases on this worksheet, a should equal 1. Okay, so you don't really have to worry about a. But b is the coefficient multiplied by x, and we said c is the constant with no variable attached to it. So when there's no coefficient or number in front of the variable, it's automatically 1. Okay, so we can see that in this case, b equals 1 and c equals negative 90. Okay, make sure you include the plus minus sign. So we want two numbers whose product is c, or negative 90, and whose sum is b, or positive 1. Okay, so we want two numbers that multiply to negative 90 and add to positive 1. So let's write out the factors for negative 90. Okay, so basically we're just saying what times what is negative 90. Well, we can do 10 times negative 9. We can do negative 10 times positive 9. And we can do negative 45 times 2. Okay, and really you can stop when you have two numbers that add to positive 1. Okay, so do we have that? Yes. Okay, if you look at 10 and negative 9, 10 plus negative 9 would give us positive 1. So we're going to use those two numbers when we factor. Okay, so you're going to write two sets of parentheses. And since it begins with m squared, each set of parentheses is going to begin with m. Okay, that's because when you do FOIL, you do m times m, you'll get m squared. So you begin with m in each set of parentheses, and then just use these two numbers right here, 10 and negative 9. So we have positive 10, and we have negative 9. Final answer. Okay, if you want to double check, you can use FOIL or distributive property to see if you get this answer. Okay, you can check your answers on pages 3 and 4, but as you can see, they got the same answer as me. Okay, the order that you multiply does not matter. So if you did positive 10 first and the negative 9 second, that's the same thing. Okay, please pause and try number 9. You want two numbers that multiply to 40 and add to negative 13. So this equation is in the form of ax squared plus bx plus c, but instead of x, they use the variable k. All right, we can clearly see that c is positive 40. And the coefficient in front of the x is b. We can see that b is negative 13. Okay, so we're going to write out the factors for 40. And we can stop when we find a pair that adds to negative 13. So what times what is 40? 10 times 4 works. Negative 10 times negative 4 works. 8 times 5 works. Negative 8 times negative 5 works. Okay, do we have a pair that adds to negative 13? Yes, we do. Okay, negative 8 plus negative 5 equals negative 13. So we're going to use those two numbers. Once again, you want two sets of parentheses. And since our variable is k, we're going to start each set of parentheses with a k. Okay, that's because we want a k squared when we use FOIL or distribute, and k times k will give us k squared. All right, so we have k and k, and then we just want to use the negative 8 and the negative 5. Minus 8 minus 5, that's it. Final answer. So for some of these problems, a will not equal 1, but we can make it equal to 1 by factoring in advance. So in this case here, we can see that a equals positive 2, but we want it to equal 1. So if a does not equal 1, you want to factor out that number first. All right, so let's do that. So since a equals 2, I'm going to factor out a 2 as my first step. And then you just have to divide each of these terms by 2. So 2k squared divided by 2. Well, the 2's will cancel, and you're just left with k squared. 22k divided by 2. 22 divided by 2 is just 11. And we still have the k. And finally, 60, positive 60 divided by 2 is positive 30. Okay, so now we're going to be working with this here. We have to factor this part in the parentheses. So now if I line these terms up with the ax squared plus bx plus c, we can see now that there is no coefficient in front of k squared, so a equals 1, and we can continue from there. We can see that b is 11, and we can see that c is 30. Okay, so we want to write out the factors for 30, and we can stop when we find a pair that adds to 11. So what times what is 30? 6 times 5, 3 times 10, negative 6 times negative 5. So we can clearly see we already have a pair that adds to positive 11. Okay, 6 plus 5 is positive 11. So we're going to use those two terms in order to factor this. All right, so now we want to keep the 2. And since we have k squared, on my two sets of parentheses, I am going to start with a k. All right, and then you just want to use the 6 and the 5 in your parentheses. So we have positive 6 and positive 5. Final answer. So if I can give you some hints on number 21, you want to factor out the 2 first, and then proceed with the ax squared plus bx plus c. On number 26, factor out a 6 first. 22, factor out a 4 first. 20, factor out the 5 first. 16, factor out the 5 first, and so on. Okay, once you factor out the a term, and then you have a equals 1, you can do the problem just like the other ones.